Okay, so this is the data table you should have gotten. The final burette reading is 4.70 milliliters. Initial burette reading is 0 milliliters. In order to determine the molarity of the acid, we need to complete the volume of base. So I take my final minus initial, and I get 4.70 milliliters. And I'm going to complete it for the hydrochloric acid as well. 8.30 minus 4.70 gets me 3.60 milliliters. And then let's solve this on the side jaw. To determine the molarity of acetic acid, I need to find Ma using MbVb equals MaVa. So that's what I'm going to do. So keeping my numbers visible, I'm going to write out my guess method for acetic acid. So that's what I'm going to write down, acetic acid. And so my MbVb, MaVa. My MbVb, my Ma is what we're looking for. Va, we start off with 5 milliliters. And so now I write out my equation, y'all. So that's what I'm going to do. MbVb equals MaVa. To get Ma by itself, I divide both sides by Va. And so I'm going to write down Ma equals, so MbVb over Va. Now that I have Ma isolated, I'm going to be substituting my values. So Mb, just say, looking over on my left-hand side and copying down the number situation here. So my calculator answer is 0.235 molar, but keeping sig fig, I'm going to use the fewest amount, and that's 1, and so I get Ma equals 0.2 molar. That's for acetic acid. For hydrochloric acid, I'm going to scroll over here and work that out as well. Hydrochloric acid. Listing my variables. Okay, so Mb, same molarity. Volume, not quite the same. We're looking for Ma. Va, we had the same. Okay, so let's move over to the side, write down my equation, isolate the variable I want, substitute my values, and in my calculator I get this value here, rounding to sig figs. I get 0.2 molar. So it looks like both values are 0.2 molar. Cool deal. Let's answer the post-lab questions. So define a neutralization reaction. Well, the neutralization reaction is when an acid reacts with base to form a salt and water. And just a reminder, y'all, the salt is just an ionic compound. Number 2, write the neutralization reaction that occurs when sodium hydroxide is added to acetic acid. So to follow the format of acid reacts with base, I'm going to write the acid first. So HC2H3O2, that's acetic acid, reacts with sodium hydroxide. I'm simply switching my cations. So sodium is now paired up with C2H3O2, and then we have HOH. Remember, that's another way of writing water. HOH. Okay, now we want to write the neutralization reaction that occurs when sodium hydroxide is added to hydrochloric acid. So writing the acid first. And there we have it. Why did you have to add an indicator to the acid in the flask? So both the acid and the base are colorless solutions. Okay, so the indicator helps us determine the endpoint in a titration. So the endpoint is when the acid-base reaction is complete. And this leads us to question number 5. What is the relationship between H, or the concentration of hydrogen ions, and the concentration of hydroxide ions when the endpoint is reached in an acid-base titration? So the concentration of hydrogen ions is equal to the concentration of hydroxide ions when the endpoint is reached in an acid-base titration. So number 6, we're going to use the guess method in order to solve this problem. So the guess method, I'm going to underline my values here. This is the base, so MB, VB. If 30 milliliters of 0.5 molar KOH are needed to neutralize, again we have this here, 10 milliliters of my acid, so VA, and we have an unknown concentration, and that's what we're looking for. So this is my MA. What is the molarity of hydrochloric acid? So MB, VB, MA, VA. So the concentration, 0.500 molar 30 milliliters. We're looking for molarity of the acid. And we have the volume of the acid. Equation time. MBVB equals MAVA. To isolate MA, we divide VA on both sides. So I'm writing down what happens after that. Substituting our values, y'all. So once we plug this into the calculator on 0.5 times 30 divided by 10, we get 1.50 molar for the concentration of my acid. Keeping 3 sig figs because the few sig fig is indeed 3. Okay, y'all. That's it for the post-lab analysis questions, y'all. Have a good one.